Hey everyone, today I want to talk about quadrants in the unit circle. Now, you know that the unit circle, just like the coordinate plane, has 4 quadrants, 1, 2, 3, and 4. But quadrants in the unit circle work a little differently in terms of what trig function belongs or what trig function's terminal side ends in that particular quadrant. In the 4 quadrants of the unit circle, we must be able to identify where a terminal side of an angle resides, or lies, or tells the truth. That's not funny. Here's our unit circle. There's, there it goes. I thought it was there for a lot longer. Hi, you're back. That's great. Okay, so the acronym All Students Take Calculus helps us identify where these angles or their terminal sides are going to be. Now, let's do a little bit of drawing. This is quadrant 1, this is quadrant 2, down here is quadrant 3 obviously, and then we have quadrant 4. Now, all students take calculus follow that same pattern. All, or A, is in quadrant 1. Students, or S, is in quadrant 2. T is in quadrant 3. And C is in quadrant 4. Now, what does that mean? It means that all 6 trig functions are positive in quadrant 1. Every single thing is positive in quadrant 1. And here's why. In quadrant 1, we have ordered pairs that are positive and positive. Every single combination of the ratios of all 6 trigonometric functions must end up being positive because of this fact. Now, when we go to quadrant 2, that's when things change a little bit. S stands for sine. Now, because sine and cosecant are inverses of each other, cosecant also is positive here. So sine and cosecant are both positive in quadrant 2. That means that every other function, all 4 of the other ones, are not positive in this quadrant. Only sine and cosecant. And the reason for that is because sine is a y value. And remember, in quadrant 2, our ordered pairs are negative and positive. Positive part being the y value. Let's go to quadrant 3. As you can imagine, you're probably getting the hang of it. T stands for tangent. Now remember, tangent's inverse is cotangent. Only tangent and cotangent are positive in quadrant 3. Now the reason for that is because our ordered pairs are negative, negative. Well, remember that tangent is sine divided by cosine. If a negative sine divided by a negative cosine is what I'm looking at, tangent's going to be positive because a negative divided by a negative is always a positive. Cotangent is the same way, obviously, because it's just the inverse operation. The last quadrant 4 is C, which stands for cosine, and its inverse secant. Only cosine and secant are positive in quadrant 4, and that is because our values of ordered pairs are positive and negative, where cosine is going to be positive. It's the only 2 functions that are going to be positive there. Now again, just to recap, everything's positive here. Only sine and cosecant are positive here. The other 4 are negative. Only tangent and cotangent are positive here. All other 4 are negative. And only cosine and secant are positive here. The other 4 are negative. Let's try some examples. They weren't supposed to do that all at once. It's okay. I'll leave that up actually. Example 1. Name the quadrant in which the angle theta lies if sine of theta is greater than 0 and cosine of theta is greater than 0. Well, that's kind of a dead giveaway. When both sine and cosine are positive, the only place we can be is quadrant 1. Now again, we're going to be doing this or figuring these out by kind of like a process of elimination. First, sine of theta is greater than 0. We know that it's either 2 choices, quadrant 2 or quadrant 1. But because there is another stipulation or another rule here, cosine is also greater than 0, meaning positive. We're eliminating choice 2 here, or quadrant 2, because it's got to be in quadrant 1. So the answer for example 1 is quadrant 1. Let's try example 2. Name the quadrant in which the angle theta lies if tangent of theta is greater than 0 and cosine of theta is less than 0, meaning where tangent of theta is positive and cosine of theta is negative. So the question is, why don't they just say that? Well, because that's not mathematical, and it's a little weird too. So let's just try to figure this out. Tangent of theta is greater than 0, meaning positive. There's only two choices it could be, 3 or 1, but look at the second one, or the second rule. Cosine of theta is less than 0. Well, if cosine is less than 0, can't be here, because cosine is positive here. Our answer is quadrant 3, because that's the only place that tangent alone is positive. Example 3. Secant of theta is greater than 0, and sine of theta is less than 0. All right, well, let's take the first one and go from there. Secant of theta is greater than 0 or positive in quadrants 4 or quadrant 1. So it's either 4 or 1. The second part of this problem is going to tell us which one it is, though, because it says sine of theta is less than 0, meaning it's negative. So it can't be in quadrant 1. It's got to be in quadrant 4, because sine of theta is negative in that section. So we have a 4 here. Name the quadrant in which the angle theta lies if cosine of theta is less than 0 and cosecant of theta is greater than 0. All right, well, let's take the first part of this and go from there. Cosine of theta is less than 0, meaning negative, so it certainly can't be quadrants 1 or 4. It's going to have to be in 2 or 3. Now, the second part is going to be our giveaway. Cosecant of theta is greater than 0. Well, quadrant 2 is the only quadrant that has a cosine negative and a cosecant positive. Can't be 3 because cosecant's not positive here. So we have a quadrant 2. And would you look at that? We've got all 4 answer choices. Things to remember about this video. Number 1, all students take calculus. And they might not, but they do in terms of this video. Number 2, if one part of the function is positive, we can already determine it's only going to be in 2 places. The choices limit to 2 at that point, right? So if I give you cosine of theta is positive or greater than 0, we know that it can only be in quadrant 1 or quadrant 4. It eliminates itself from 2 or 3 because cosine values are negative on that side, right? So take your first part of that problem, identify which 2 it can be, and then take a look from there to eliminate the other choice. See you next time.